Hi and welcome. In this video, we continue our study of quadratic functions and we will see some further examples on transformations of quadratic functions. First of all, let's consider this quadratic function x squared plus x minus 1 and try to find x, y, and o reflections of this function. Starting with x reflection, we know we get that reflection by multiplying a function by minus 1, that is minus f of x, which is minus x squared minus x plus 1. Going for y reflection, we replace x with minus x, that is we find f of minus x, that is minus x all square, plus minus x minus 1, which is x squared plus times minus is minus x minus 1. In order to find the ORIF, we find minus f of minus x, that is the x reflection of the y reflection. Since we already know the y reflection, which is x squared minus 1, we find the x reflection of this. In other words, we multiply everything by minus 1. As a result, we get minus x squared plus x plus 1, which is the O reflection of the given quadratic function. Next, consider the function 2x squared minus 4x plus 6 and find all transformations in this function. To that end, we go ahead and take 2 as a common factor outside. As a result, we get x squared minus 2x plus 3 inside. Completing the square of these two terms, we get that x squared minus 2x plus 1 and minus 1 plus 3. As a result, these three terms turn to x minus 1 whole square minus 1 plus 3 is 2. Multiplying back 2 with two terms inside, we get that 2 times x minus 1 whole square plus 4. Hence, we have a right shift of 1 unit, upwards shift by 4 units, and shrinking by 2 units. Next, consider y is equal to g of x minus 1/2 x squared plus 2x minus 1 and try to find all transformations in this function. Like always, we take minus 1/2 as a common factor outside. As a result, we get x squared minus 4x plus 2 inside. Completing the square of these two terms, x squared minus 4x plus 4 minus 4 plus 2. As a result, x squared minus 4x plus 4 turn to x minus 2 all square minus 4 plus 2 is minus 2. Multiplying 1 over 2 with both terms inside, we get that minus outside. 1 over 2 times x minus 2 all square. 1 over 2 times minus 2 is minus 1. Therefore, what do we have inside is a right shift by 2 units, downwards shift by 1 unit, expansion by 0.5 units, and because of this minus outside, we have also an x reflection. Next, consider the same function y is equal to g of x and find the x and y intercepts of the graph of this function. To find the y-intercept, we let x to be 0. Substituting 0 instead of x, we get y to be minus 1. Hence, the y-intercept is 0 and minus 1. To find the x-intercept, we let y to be 0. In other words, minus 1/2 x minus 2 all square minus 1 equals to 0. That minus vanishes as we multiply both sides by minus 1. In addition, we multiply both sides by 2. As a result, we get x minus 2 all square minus 2 equals to 0. Moving 2 to the other side, x minus 2 all square is equal to 2, and taking the square root, we get that x minus 2 is equal to plus minus square root of 2. For the first solution, x minus 2 is equal to plus square root of 2, from where x is equal to 2 plus square root of 2, and for the second solution, x is equal to 2 minus square root of 2. Hence, the x-intercept of the graph of this function are 2 plus square root of 2 and 0, and 2 minus square root of 2 and 0. Furthermore, find the x, y, and o ref of the function y is equal to g of x. For x ref, we multiply simply function by minus 1. As a result, we get 1/2 x squared minus 2x plus 1. And for y ref, we replace x with minus x. As a result, we get minus 1/2 x squared minus 2x minus 1. And for ORIF, we find the XRIF of YRIF, that is the XRIF of this thing, multiplying this thing with -1, we get 1/2 x squared plus 2x plus 1 is the O reflection of this function y is equal to g of x. Thanks for watching and good learning.